Balaji. So I would like to share about my experience of starting an LinkedIn post series titled Holy Triple 90. So it's basically about sharing my learning for the next triple 9 days, not on a consequent basis, but as and when I find time, I'll be posting it. So it started as day zero. So before 3 months, I was writing a post in LinkedIn wherein I explained about my interest towards contributing to the social welfare of my apartment. So I was acting as an vice president and president, where we used to manage various issues during the weekends, and we used to work with the facility management, accounts team, and other departments to run the residential area smoothly, all the day-to-day operations. So there we were facing multiple issues, and the triple nine is an unique number which which formed because of our communication, which we have to do on a regular basis to different residents. Like we have around 1500 plus residents, so we used to share the mail on the ninth minute. So that's like a holy number we used to think, and based on that I wanted to follow a series of blog post. So that's the reason we kept it as hashtag holy triple 9D. And in the day one, I given the background of what exactly I'm going to build, what is my tech plan, and what are the tech stack we are going to use. So I outlined here, and here you can see that I'm going to make my application work in my local environment and Docker based, Kubernetes based, and similarly on the cloud, local cloud Docker and cloud Kubernetes. So on the day two, I was explaining about the local application working of Python, and in the day three, I shared about working of the application from the local to the Docker environment, how we are migrating. And day four is about general learning about my craft work, which I shared with my kid. And day five is about onboarding application into Kubernetes with an hello world by explaining the basic architecture of the Kubernetes and what are the system requirements. And day six is about the learnings as a part one in Kubernetes related to my application. And day seven is about working of my Kubernetes application deployment in local environment with a short clip of the high level working of the demo. And now in the day 8 you will be able to view the detailed steps I have taken to deploy my application in the local Kubernetes environment, and hope it will add value and you will learn something new. I would highly recommend to follow all the day series by searching in the LinkedIn for hashtag holy triple 9D. Thank you. Hey, hello everyone. This is Balaji here. I'm going to start a project in Kubernetes. An outline of my agenda is shared here. So basically we are going to deploy an application in Kubernetes. And here is the agenda. We'll talk a little bit about my application and what are the prerequisites. Basically, I'm using my local laptop environment to build an application and deploy it in Kubernetes. As we progress, we'll be creating the live documentation on the steps I am performing for bringing up my Kubernetes based application deployment. So to begin with, this is my overview of the application. So we are going to deploy a microservice app which is based on Python, which uses REST API. It performs the CRUD operations: create, read, update, and delete. It has an UI interface and a Swagger interface. The backend data is stored in MongoDB, and we have some background celery task as well, which performs some useful operation based on the data available in my application. Let's get started. So to begin with, we need to start the Minikube environment. So Minikube is basically an minimum version of Kubernetes environment which can run in a local setup in your laptop or desktop. So currently my Minikube version is 1.36.0. So let's start my Minikube service. So basically my local laptop acts as both the worker node and the control node. So control node is basically the server part of Kubernetes, and worker node is like the client part of Kubernetes. So both the service runs in my local laptop. So these are the prerequisite before you start. So you need a Visual Studio Code editor. I have my Visual Studio Code ready, installed, and I have my GitHub account as well. So basically here is my GitHub account. So I'm just quickly logging here, and this is my project which I'm going to deploy. I'm more interested in this particular branch, animal KB Kubernetes environment. I have the Docker Hub account as well. Docker Hub. I'll just do a test sign up. Okay, so I have my GitHub account ready, Docker Hub account ready before I begin the application deployment. And I'm going to start my Docker desktop engine, which is already up and running, the Docker desktop, and then the Minikube. I'm going to check the status of my Minikube. For starting the Minikube, and the virtualization service should be running, like the Docker desktop, to manage the images. Currently the Minikube is in stop state, so I'm just going to start it. It manages the minimal version of Kubernetes services which is required to host my application in my local environment. So let's get started. We'll wait for the services to come up. And here we go, we have the minikube services started. I'm just going to say minikube status, and the control plane host, it's running fine. And we have the kubectl client interface to interact with the local running Kubernetes cluster and to create the necessary pods. We'll be using heavily the kubectl command. If you don't have already, please install it so that it gets integrated and working with your minikube cluster, Kubernetes cluster. And the kubectl, as I mentioned, and we need the extension of the MongoDB under the VS Code IDE and the Python version 3.10. So these are the prerequisite. So let's get started. Firstly, I would like to clone my application project from the GitHub. So before I do that, let me check the current running status of my Kubernetes. So currently I have some pods running here. So, but what I want to do is I want to delete the current environment and working under the namespace. So I'm just going to delete the current working Kubernetes deployment. So to give you an high level overview, so what is going to happen, I'll just share the overview. So basically we are going to deploy this application, animal knowledge based application architecture. So this application is having a front end, a back end, and an asynchronous task execution called Celery with the MongoDB, the backend to store the database. We are using the Flask framework from Python for creating our application, and the backend is the API, REST API. We have the core application logic to perform the CRUD operations, create, read, update, and delete, which will interact with the MongoDB. And the backend Celery, to begin with, it has the broker running, Redis broker. So once we start the broker, we have the Celery worker and beat. So worker executes the task we want, and beat schedules the task when to execute. And flower is the Celery flower is the monitoring utility for the task which we are going to run in the background. So as we seen in the previous post of my LinkedIn, so initially we deployed this application in the local environment, without Kubernetes or Docker containers, and then with Docker and in the Kubernetes environment. So this is how we are going to do now. This is our current expectation for my application to be running in Kubernetes. So Kubernetes is basically a container orchestration utility. Consider an application will have different components, or we call as microservices. Each of the component can be restarted independently without affecting others. That is the main application of microservices, and we are going to use take the advantage of microservices and deploy each microservices in a different pod. Kubernetes has multiple objects. Pod is one of the object. Namespace, secret, the deployment, and the volume, service, config map, ingress. So these are the different objects, the technical point of Kubernetes, and each of the object will be used to host our application. So basically let me share that. So this is the overall architecture about the Kubernetes for managing my application. Kubernetes, we have cluster environment. So basically it has the control plane and the worker node. So in the control plane, we have the API services running, etc, controller, scheduler. So these are the short description about each of the background services, and these are the main components, control plane components: Kube API server, etcd, control manager, Kube scheduler, and these are the slave. These slaves, otherwise called as worker nodes, which host our application in terms of minimal running unit called pod. These are the component of the worker node: kubelet, kube proxy, and the container runtime environment. And this is the client kubectl we are going to manage for performing the deployment of the pods and do the necessary debugging and troubleshooting as part of our building our environment within the Kubernetes. And if you see here, these are the different Kubernetes objects which we are going to create. We can create the Kubernetes deployment using the imperative method or declarative method. So imperative method is using the command line kubectl to create the working application deployment, or use the YAML file with the declarative method. These are the overview of the different Kubernetes objects. So it is mentioned here: the workload objects, the service and networking objects, storage objects, configuration and management objects, security objects, and metadata objects. So each and every objects, if you want to create, it can be done through YAML file. Suppose in our application currently we have a folder called K8s. K8 means K followed by, between the K and S we have 8 letters in Kubernetes. So that is the meaning of K8s. And these are the YAML file which we are going to use to deploy our application. So currently all the resources which are running under the namespace of my application animal-kv is deleted. So if you take a look at here, Kubernetes, so there are no resources found in my animal KB namespace. And I'm going to also delete my existing working GitHub project path. So I'm going to download my application from GitHub. So going to my application project repo, just going to copy the URL through the SSH. I'm just going to clone my project, git clone command I'm using. I'm going to check by after going into my project folder, animal bird KB UI, and I'm interested to work with the Kubernetes repo. I mean the Kubernetes branch. So I'm going to query for that. This is my branch I'm interested in. So I'm going to make sure I have the correct code in my local. So I'm going to check out my Kubernetes branch to deploy my application. So these are my folders. So each and every component of the application which I described in this picture, so the REST API is the actual application, Flask application. It has its own folder to basically build the Docker image and store it in the Docker hub, and we are going to use the same within our Kubernetes. So I'll walk you through each of the folder. So this is the backend application which is running in the Flask framework. So if I go to this particular main.py, you can see the import statement of Flask framework. And to build the Docker image of the Python application which is running in the Flask framework, we have a Docker file. We are defining the necessary packages required to construct the application under the requirements.txt. And here we have the beat. Beat is the celery beat for scheduling the task which is going to run in under the celery. So basically the celery beat will look for the Redis broker service. So we are pointing to that as part of a container. The Redis service will be running as one of the pod, and we have the Docker file for that. Basically everything starts with all the Docker file starts with the Python as the base image 3.11. If you take a look, it starts with the 3.11 base image Python, and we have the celery flower to monitor our celery tasks, and we have the celery worker, which also looks for the Redis broker service, and then the backend code, what task has to be executed under the celery worker, which is written in a Python file. and we have the Docker file to build the celery worker container image. Okay, then let's get started with our Kubernetes. We have the utils as well. This is the score calculator. Basically, we are making use of the CRUD operation to input an information about animal or bird, and out of the data present under each row, we are trying to make out a score based on the relevant information about that particular animal or the bird. So that is the score calculator. These are the different Kubernetes objects which we are going to make use of in our application. So we'll straight away get into the deployment of the application. So currently the application is running on port 5000. I will just quickly check. Okay, it's not running, so let's get started. So first I wanted to deploy the application with starting with the namespace. So I want to apply we can use kubectl apply -f followed by the Kubernetes 00 -namespace. Okay, so we just created our namespace for our application. Within this particular namespace, we'll host all our resources of Kubernetes in terms of objects. So currently we have the kubectl currently we have the namespace animal kb active, which is created 39 seconds ago. Next in the order, I wanted to create the config map.yaml. So basically it is the config. I will just walk through the namespace YAML. So namespace YAML is very short and sweet file. Doesn't have much information. It talks about the API version, kind, metadata, and the name. So these are the default key value pair which is present in most of the Kubernetes YAML files. The API version, kind, what is the object kind, namespace is the object kind, and the metadata name for the name of the namespace is animal kb. And the next we are going to use is config map.yaml. So these are the defining the different port number of my application component, what is the MongoDB host, what is the port of MongoDB, what is the MongoDB name, and the Redis host name, Redis port number, the environment of my application. So everything is defined under the config map, and if any secrets I'm going to use for my application, that also is used here, defined here. So I'm just going to deploy my next Kubernetes object called config map. We are done. So basically I can check using the secrets here. The secret is an object which we have defined, animal kb secrets, and you can see it here. It is deployed 17 seconds ago. We have two data. So these are the data it is referring to. And the next we are going to deploy is the MongoDB secret. Okay, under the MongoDB secret PVC deploy, we have multiple objects. To begin with, we have the secret for MongoDB, which is the username and password to access the MongoDB for the CRUD operations. And we have the persistent volume claim. So basically the volume information for the MongoDB, where it has to read and write the data, and the deployment. So we want to deploy it as a container, MongoDB container. The container image name and the namespace under which the container has to be deployed. Every specification will be mentioned here in detail. So we'll just get going. After the MongoDB secret and the pod deployment, we'll start with the Redis. After the Redis, we'll start with the config map secrets. So the config map previously we deployed is only for the port number, mainly the non-critical one. The port number, the service name and the port number, and the application or the Flask secret key and the JWT token. And now this particular config map secrets for the Redis, what is the secret we are going to use, and the MongoDB, how we are going to access the MongoDB by passing the username and password under the port number, under the namespace animal-kb. So basically I'm going to just deploy this, and next is the main Python Flask application deployment, Kubernetes deployment object. This is the name of my application which is going to run under the Kubernetes pod. So basically I'm going to point to the YAML file. It created the deployment and the service for the application. So these are the different services it is using. And next is the Celery worker. And after the Celery worker, I wanted to start the Celery beat. And after the Celery beat, Celery flower. And after that, the ingress, the communication between our local and the pod, how we want to establish on which port for my application. So it is mentioned here. I'm just going to start the deployment of the ingress service. And that's it. I want to have one alias as well. I want to refer the MongoDB as MongoDB as well as Mongo. Kind of a shortcut. Suppose if any of my code is trying to access my application Mongo with the database MongoDB as Mongo, it has to still work. So that's why this alias we are going to create. Alias again is an object using the service as the object. That's it. We are done. Now I'm going to check the different pods running under my namespace. So all the pods are up and running. Now what we are going to do, we are going to access, before we access my application in the local Kubernetes, I wanted to make sure the necessary port forwarding from my local application to the pod is working fine. So these are the services currently hosted under the Kubernetes. So these are the different services. This is my Python application API, the Celery flower on port 5555, MongoDB and the Mongo on port 27017, and the Redis on port 6379. And here you can see the different duration as well from when these services are running. So now we'll be using the port forward option. So basically these are the port forward. This is my kubectl port forward. Before that I want to start my MongoDB. So I want to access my MongoDB locally. So currently if you see, I'm trying to use my local 27018 to access the pod service which is running in 27017. So in order to establish the connection from 27018 to 27017, I need to enable this service. Port forward. Okay, here we go. We have this port listening on 27018, and I will open another tab to start the application. My Python application basically running on port 5000 locally within the pod environment. So I wanted to forward the port, my local port 5000 for the against the HTTP port 80 so that I can access my application. So this is my application currently. I already have some data, so you can see the same. Suppose if I wanted to, the last time my Celery task executed time is mentioned here, and I wanted to, before I open the Flower interface to monitor my task, I need to have the port forwarding running. So currently it is not enabled, so I'll just go ahead and start the port forward for the Flower Celery Flower service in a new tab. So here we go. Here we have the Celery worker is running, and these are the score which is being calculated in the background. So for the data I have in this first row, based on the data under the fields name, category, origin, sleep pattern, food habits, and fun facts, it is calculating a score using a Python library. And we can also edit the CRUD operations using this UI, or we can use the same Python application using the Swagger interface. Also we can access our application. So here we go, we can just try it out for the read operation. Execute. So currently what are the data we have in the MongoDB? A current data, it is been displayed here in the JSON format. I can also download the data. we have the data here downloaded in the JSON format. So basically we have totally 1, 2, 3 documents under the MongoDB. So if I want to see that in the database level also, I can check here under the animal DB. These are the collections. Animals is the collections I have. Under the animals collection, I have this many documents. Okay, thank you for watching. See you next time. Bye.